National Electrical Code, or NEC, prohibits the installation of overcurrent protection devices, or OCPs, such as circuit breakers or fuses, in bathrooms for safety reasons. The theory behind this prohibition is to prevent electrocution hazards. Bathrooms are inherently wet and humid environments, increasing the risk of electrical shock. OCPs are designed to trip when the electrical current exceeds a predetermined threshold, but in a bathroom, moisture can impair their proper operation. Water or steam can create a conductive path between the OCP and the metal components of the bathroom, such as fixtures, appliances, or plumbing. This can lead to electric shock if someone comes into contact with a live wire or fixture. The prohibition of OCPs is also meant to reduce fire risk. Overloaded circuits can cause electrical fires. In bathrooms, where moisture and flammable materials such as towels and hairspray are present, a fire can spread quickly and dangerously. OCPs are designed to prevent fires by tripping when the current exceeds a safe level. However, in a bathroom, moisture can corrode or damage the OCP, affecting its ability to trip properly. This can lead to the circuit carrying dangerously high current and potentially sparking a fire. Another consideration is to ensure proper functioning of bathroom appliances. Bathroom appliances, such as hair dryers, electric toothbrushes, and razors, rely on electricity to operate safely. OCPs can interrupt the power to these appliances if the current exceeds the allowed threshold. In a bathroom without an OCP, these appliances could continue to draw excessive current, potentially leading to overheating, damage to the appliance, or an increased risk of fire. Additional considerations include firstly, ground fault circuit interrupters, or GFCIs, which are required in bathrooms and provide an added layer of protection against electrocution hazards by tripping when they detect a small imbalance in electrical current. Secondly, receptacle locations in bathrooms must be placed a specific distance from sources of water such as showers and bathtubs to minimize the risk of shock. Thirdly, all metal components in the bathroom must be properly grounded to provide a low resistance path for electrical current to flow in the event of a fault. By prohibiting OCPs in residential bathrooms, the NEC seeks to enhance safety, prevent fire risks, and ensure the proper functioning of bathroom appliances. GFCIs are essential safety devices that protect against electrical shock. They work by monitoring the current flowing through a circuit and quickly interrupting the power if they detect an imbalance, which could indicate a ground fault. A ground fault occurs when electricity flows outside its intended path, such as through a person touching a live wire or a faulty appliance. In a bathroom, where water is often present, the risk of ground faults is significantly higher, making GFCIs a critical safety measure. The NEC mandates GFCI protection for all 125-volt, 15 and 20 amp receptacles in bathrooms. This requirement extends to other areas where water is prevalent, such as kitchens, laundry rooms, and outdoor locations. The installation of GFCIs is straightforward, and they can be easily retrofitted into existing electrical systems. GFCIs are available in several forms, including receptacle type, circuit breaker type, and portable type. Receptacle type GFCIs replace standard electrical outlets and provide protection at the point of use. Circuit breaker type GFCIs are installed in the electrical panel and protect the entire circuit. Portable GFCIs are useful for temporary applications, such as construction sites or outdoor events. Regular testing of GFCIs is essential to ensure they are functioning correctly. The test button on the GFCI should be pressed monthly to verify that the device trips and interrupts the power. If the GFCI fails to trip, it should be replaced immediately by a qualified electrician. Proper grounding is another crucial aspect of electrical safety in bathrooms. Grounding provides a low-resistance path for electrical current to flow in the event of a fault, helping to prevent electrical shock and equipment damage. All metal components in the bathroom, including pipes, fixtures, and appliance housings, should be properly grounded. The grounding system consists of a grounding electrode, such as a ground rod or metal water pipe, connected to the electrical panel. From the panel, grounding wires extend to each outlet and fixture, providing a path for fault current to return to the source. The NEC specifies the requirements for grounding systems, including the size and type of grounding conductors, as well as the methods for bonding metal components. Proper grounding ensures that fault current will quickly trip a circuit breaker or GFCI, de-energizing the circuit and preventing electrical shock. In addition to GFCIs and grounding, other safety measures can further reduce the risk of electrical hazards in bathrooms. These include using only approved electrical appliances and fixtures, keeping electrical devices away from water sources, and avoiding the use of extension cords. Electrical appliances used in bathrooms should be certified by a recognized testing laboratory such as Underwriters Laboratories or OL. These appliances have been tested to meet safety standards and are less likely to cause electrical hazards. It is also important to keep electrical devices away from water sources such as sinks, showers, and bathtubs. Water is an excellent conductor of electricity, and contact with water while using an electrical device can result in electrical shock. Extension cords should be avoided in bathrooms whenever possible. Extension cords are often used improperly, which can lead to overheating, damage, and electrical shock. If an extension cord is necessary, it should be a heavy-duty cord and should be used only temporarily. Regular inspections of the electrical system in the bathroom can help identify potential hazards before they cause problems. Look for damaged outlets, frayed wires, and other signs of wear and tear. If any problems are found, they should be repaired immediately by a qualified electrician. The twin 200-amp panels located in the newly finished basement should be relocated out of the bathroom. The NEC prohibits the installation of overcurrent protection devices in bathrooms due to the increased risk of electrical shock and fire hazards associated with wet and humid environments. The moisture can impair the proper operation of OCPDs, leading to electric shock if someone comes into contact with a live wire or fixture, or causing a fire if the OCPD fails to trip properly. GFCIs are required in bathrooms to provide an added layer of protection against electrocution hazards by tripping when they detect a small imbalance in electrical current. Receptacles in bathrooms must be placed a specific distance from sources of water to minimize the risk of shock, and all metal components in the bathroom must be properly grounded to provide a low resistance path for electrical current to flow in the event of a fault. Firstly, the primary concern is electrocution prevention in a damp environment. Bathrooms, by their very nature, present the higher risk of electrical shock due to the presence of water. Overcurrent devices themselves are not inherently waterproof or resistant to humidity. Secondly, consider potential corrosion and malfunction. The humid environment can cause corrosion of the metallic components within the overcurrent protection devices, leading to a malfunction. This malfunction could prevent the device from tripping in an overcurrent situation, thereby increasing the risk of electrical fire. Thirdly, improper operation due to humidity can be a factor. Humidity can affect the insulation properties of the overcurrent protection device, potentially leading to leakage current or improper operation. Fourthly, there is the issue of accidental contact and tampering. Bathrooms are often smaller spaces, increasing the likelihood of accidental contact with electrical equipment, especially by children. Tampering with overcurrent devices can also lead to dangerous situations. Fifthly, the NEC prioritizes minimizing risk in vulnerable locations. The NEC aims to reduce potential hazards in areas where people are most vulnerable, such as bathrooms, where they might be barefoot and in contact with water. Sixthly, there's the enhanced protection from GFCIs. While GFCIs provide significant protection against ground faults, they do not protect against overcurrent situations. The prohibition of OCPDs in bathrooms complements the use of GFCIs to create a safer environment. Seventhly, there's a potential for misidentification and incorrect use. In a multiple panel situation, a homeowner might mistakenly reset a breaker in the bathroom panel thinking it controls a bathroom circuit when it actually controls a circuit elsewhere in the house, potentially leading to confusion and hazards. Eighthly, there is the maintenance difficulty in a confined space. Servicing and maintaining overcurrent devices in a small, damp bathroom can be challenging and increase the risk of electrical shock for the person performing the work. Ninthly, the NEC adopts a conservative approach to safety. The NEC generally takes a conservative approach to electrical safety, erring on the side of caution to minimize risks and prevent accidents. Finally, there's a historical precedent based on safety incidents. Past incidents involving electrical accidents in bathrooms have likely contributed to the prohibition of OCPDs in these locations, reinforcing the need for stricter safety measures. In summary, the prohibition of overcurrent protection devices in bathrooms is a multifaceted safety measure designed to prevent electrocution, reduce fire hazard, and ensure the proper functioning of electrical systems in a high-risk environment. The presence of two 200-amp panels in the newly created bathroom poses significant safety risks and violates the National Electrical Code, or NEC, regulations. The NEC, which is the standard for safe electrical installations, specifically prohibits the installation of overcurrent protection devices, or OCPDs, such as circuit breakers and fuses, in bathrooms of residential dwellings. The primary reason behind this prohibition is to minimize the risk of electrical shock and fire hazard in an environment that is inherently wet and prone to humidity. When electrical components are located in a bathroom, the moisture and humidity can compromise their functionality, leading to potential malfunctions and dangerous situations. One of the most significant concerns is the increased risk of electrocution. Bathrooms are areas where people often come into contact with water while using electrical appliances or fixtures. If an overcurrent protection device is located in the bathroom, the moisture can create a conductive path, allowing electricity to flow through unintended routes. This can result in a severe electrical shock if someone comes into contact with a live wire or a faulty appliance. Moreover, the humidity in bathrooms can also lead to corrosion of the electrical components within the overcurrent protection devices. Corrosion can degrade the insulation and protective layers of the devices, making them more susceptible to failure. When an overcurrent event occurs, such as a short circuit or an overloaded circuit, a corroded OCPD may not trip as quickly or reliably as it should. This can lead to excessive heat buildup, arcing, and ultimately a fire. The presence of flammable materials in bathrooms, such as towels, toiletries, and personal care products, further exacerbates the fire risk. Even a small electrical fire can quickly escalate into a major blaze, endangering the occupants of the home. In addition to the electrocution and fire hazards, having overcurrent protection devices in a bathroom can also interfere with the proper functioning of electrical appliances. Many bathroom appliances, such as hair dryers, curling irons, and electric razors, are designed to operate within specific voltage and current ranges. If an OCPD trips unnecessarily due to moisture or corrosion, it can disrupt the power supply to these appliances, causing them to malfunction or fail altogether. This can be particularly problematic if someone is in the middle of using an appliance when the power is suddenly cut off, potentially leading to personal injury or property damage. To address these safety concerns, the NEC mandates that overcurrent protection devices be located outside of bathrooms in easily accessible and dry locations. This ensures that the devices are not exposed to moisture or humidity, reducing the risk of corrosion and malfunction. By keeping the OCPDs away from water sources, the likelihood of electrical shock is also significantly reduced. Furthermore, the NEC requires the installation of ground fault circuit interrupters, or GFCIs, in bathrooms. GFCIs are designed to detect even small imbalances in electrical current and quickly interrupt the power supply, preventing electrical shock. GFCIs are highly effective in protecting against ground faults, which are a common cause of electrical injuries in bathrooms. By combining the prohibition of OCPDs with the requirement for GFCIs, the NEC creates a comprehensive safety system that minimizes the risk of electrical hazards in bathrooms. Relocating the twin 200-amp panels from the newly created bathroom is essential to comply with the NEC regulations and ensure the safety of the occupants. The panels should be moved to a dry and accessible location outside of the bathroom, such as a hallway, a utility room, or a dedicated electrical closet. The relocation process should be performed by a qualified electrician who is familiar with the NEC requirements and local electrical codes. The electrician will need to carefully disconnect the wiring from the existing panels, move the panels to the new location, and reconnect the wiring in accordance with the applicable codes and standards. The electrician will also need to ensure that the new location meets all of the necessary requirements for ventilation, clearance, and accessibility. Once the panels have been relocated, the electrician should thoroughly test the electrical system to verify that it is functioning properly and that all safety devices are in good working order. This includes testing the GFCIs to ensure that they trip correctly and verifying that the grounding system is properly installed and connected. It is important to document all of the work that is performed, including the dates, the names of the electricians who performed the work, and the results of the testing. This documentation can be useful for future maintenance inspections or insurance claims. The decision to leave the 200 amp panels in the newly created bathroom is a serious safety violation that should be rectified immediately. The potential consequences of ignoring this issue are severe, including electrical shock, fire, and even death. By relocating the panels and complying with the NEC regulations, you can protect yourself, your family, and your property from these hazards. It is always best to err on the side of caution when it comes to electrical safety. If you are unsure about any aspect of your electrical system, consult with a qualified electrician who can provide expert advice and assistance. Remember, electricity is a powerful force that should be treated with respect. By following the NEC regulations and taking appropriate safety precautions, you can ensure that your home is a safe and comfortable place to live. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is developed and updated by the National Fire Protection Association, or NFPA, and is widely adopted by state and local jurisdictions. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is designed to protect people and property from electrical hazards by providing detailed requirements for safe electrical practices. Compliance with the NEC is essential for ensuring the safety and reliability of electrical systems. Failure to comply with the NEC can result in fines, penalties, and even legal liability. It can also increase the risk of electrical shock, fire, and other hazards. When working with electricity, it is always best to consult with a qualified electrician who is familiar with the NEC requirements and local electrical codes. An electrician can help you design and install electrical systems that are safe, reliable, and compliant with all applicable regulations.